Hey guys, hope you're doing well. Um, Today we're going to be looking at combinatorics. So combinatorics, right? So that's a sub branch of discrete mathematics and deals with counting, so things like permutations and stuff, that sort of thing. So yeah, on a side note, guys, I'd really appreciate it if you do subscribe to my channel. So if you love what you see, please do subscribe. Please do share the videos with your friends. I would greatly appreciate that. Okay, cool. So let's get started. So I'm going to import the libraries from SymPy, import, number star, and then init printing. There we are. And then my symbols, X, Y, equal symbols. Right. And so yeah, so we're going to start off with Bell numbers. So Bell 3, right? And that'll be 5. Okay. So what's a Bell number? So basically a Bell number is just a number of ways a set of n elements can be split into non-empty subsets. Okay. So yeah, so that's the Bell number. Right, I'm gonna set then Bell 30. Yeah, huge number, right? And then I'm gonna create a Bell polynomial. So Bell, and then x is my variable. So there's our Bell polynomial, right? And then now we're gonna look at Bernoulli numbers. Okay, so what I'm gonna do is I'll just create and just to show you a range of numbers. Okay, so Bernoulli, right? So n, right? So for n in range, I'll go 15. Right. So they are Bernoulli numbers, right? So if I type in Bernoulli 5, right, that's 0. Okay. So Bernoulli 0 is going to be 1. So there's 1, 2, 3, 4, and then 5, 6, and so forth, right? And then Bernoulli polynomials. So Bernoulli polynomials, 5, x is a variable. Yeah, so there we are. So Bernoulli numbers are named after Jacob Bernoulli, a Swiss mathematician. Okay, and then the Bell numbers are named after Eric Temple Bell, a Scottish mathematician. Right. So yeah, cracking on. So I can also work with binomial numbers. Okay. So I'll create a formula for 4. Okay, actually, hold on. Look, 4 n in range. I'll go 10. Right. And then so print. And then binomial. And I, right, for I in range n plus 1. Right, so that will create Pascal's triangle. Okay, so that's what it is. So there's Pascal's triangle. Okay, so I can I'm gonna expand. I'll expand a binomial. So expand a binomial. Right, let's see. X plus y. Actually, no, yeah, 6. Right, there we are. So the sixth line in the binomial theorem, in the Pascal's triangle, will give you the coefficients. Okay, so here's the sixth line. So 6, 15, 20, 15, and so forth. Okay, so that's 1, 2, 3, 4, 5, the sixth line, right? And then if I go on to do, I can also expand it to the ninth line. So those will be the coefficients. I'll do the same thing again. So expand x plus y, right? The ninth line. So there we are. So 9, 36, 84, 126. Okay, that sort of thing. So you can see the gist. Okay, cool. Now we're gonna do work with binomial theorem again, right? So I can just type in binomial. I'll go with 15 and 3, right? So there we are. So 455, right? And I can create the formula if I want. So def, right? Then binomial. So n and k, right? And then so return, right? Factorial, right? Factorial n, right? And then let's divide it by, so factorial k times factorial again, n minus k, right? And then yeah, so that's the binomial formula, and then I'll just test it again. So binomial 15 and then 3. There we are. So 455, same thing again, right? So you can create your own formula as well if you wanted to and stuff here, right? And then we can look at Catalan numbers as well. So Catalan, right? N in range. I'll just go 11. Right, that will do. So there you are. That's the range of Catalan numbers. Right, so Catalan 4. Yeah, so that's 14. Yeah, so there we are. Right, so 0, 1, 2, 3, then 4. Yeah, right. And then yeah, I can create. I can also create the function as well, the formula for that. So def define, and then cut n. Right, and then so then I'll return, right? So 1 divided by n plus 1, right? Okay, right, and then that multiplies the binomial 2 times n and n, right? That should be it. Yeah, right, and then so cat 4. Yeah, okay, so yeah, floating point, but yeah, get the same thing, 14, right? Right, okay, so now looking at Euler numbers. So Euler, actually let me create the list of Euler numbers first. So Euler n, right, for n in range 12. Let's just go by 12. Yeah, so they're the Euler numbers, right? So in Euler 6, yeah, so it's going to be minus 61. Let's see, yep, minus 61. And then Euler polynomial, so Euler 6x as my variable. There we are. So that's the Euler polynomial. Okay, cool. So yeah, just a quick vid using Python and SymPy, looking at combinatorics. Okay, so I've done that video as well with Maple. That's already up online, so you can have a look. But the Maple one is just a brief one, but this is a little bit more detailed using Python. Okay, cool. So thanks for watching, guys, and have a lovely day. Bye bye.